Hey guys, this is Miss Holtz, and in this video I'm just going to be talking a little bit about vector addition. So we've talked a little bit about vectors and we've used them in different diagrams. We've used them to show displacement and velocity, acceleration, and forces on free body diagrams. So today we're going to be talking about how you would add those arrows together. So let's think about an example we've all seen lots of times. There's a car driving down the road, and we know he's going to the right because there's a vector that tells us that. So this is our velocity vector for the car. We also have an oil drop diagram underneath, and we see that the dots are getting closer together, so that means that it's slowing down. So from that, we can also see that our acceleration is pointing to the left with that acceleration vector. So let's draw a free body diagram for this scenario, for the car. So here's our car, represented by a box. And let's draw the arrows that are acting on it. So this car is on Earth. So we're going to draw the force of gravity pointing down, which is acting on the car. And we also know that this car is sitting on the ground. It's sitting on the road. So it needs to have a force from the road pushing up on it, and this would be the force, the normal force acting on the car, and it's going to be the same length approximately, hopefully, as the force of gravity. And this car is accelerating to the left, so it needs to have some force acting on it to the left. So in this case, our force is going to be friction. So here's our force of friction, and I'll label these in a minute. There's friction, and let's say that this car is just coasting, so it's not pressing the gas pedal or the brake pedal, it's just kind of coasting there, but slowing down because of friction. So now let's label these. So this is the force of gravity, this is the normal force, and this one over here is the force of friction, which is kinetic friction since we're moving. Okay, so now we're going to take this free body diagram right here, and we're going to look at how we would add these arrows together, because a lot of times we need to find the sum of the forces, which means add them all up. So let's take a look and see how we can do that. So algebraically, we've looked at this equation here. The sum of the forces equals mass times acceleration, and this sigma symbol means sum, or add them all up. And when we've done problems with free body diagrams, we've looked at the forces going in the x direction and the forces going in the y direction separately. So, we've said that the forces in the x direction would be the forces along the x-axis, which in this case is just the force of friction here. So, force of kinetic friction. And in the y direction, our forces are the normal force and the force of gravity. So we would add together normal force plus the force of gravity. But when you're looking at vectors, instead of dividing them up like this, we can just add all of these vectors together by moving the arrows around and adding the arrows together. But we have to follow a few rules for this. So there's 4 vector addition rules that we need to worry about. And the first one is vectors can be moved around and still be the same vectors. So if we go back to our free body diagram, we have these 3 vectors here, and we want to add them together, but they're all sticking to a box, so we can't do much with them there. Instead, we can move them away from the box and manipulate them over here, because these vectors are still the same magnitude. They still all have the same length that they started with, and they're all pointing in the same direction. So they're essentially the same vector, they're just in a different place. Once we have them moved around, we can line them up head to tail. That's how we need to add them together. So this is the head of our arrow, and here's the tail. So if that's the head, let's move this over here. We need to do a head to tail combination right there. So if we added these two together, we'd move this tail of this arrow onto the head of this arrow. And now to put this one on, we put the tail of this arrow onto the head of that purple arrow right there. Okay, so our next step is going to be to find the sum vector, or the resultant vector. And we draw that by starting at the tail of the first vector and pointing to the head of the last vector. So when we draw our resultant vector, or our sum vector, the sum of all the forces, we start at the tail of the first vector we added, which was this green one, and we go to the head of the pink arrow right there. And this is what we would call our resultant vector, or in this case, the sum of our forces. And so, if you notice, the sum of our forces, that arrow should be the same as this purple arrow up here. Because when we looked at our free body diagram here, these two forces are balanced. The normal force and the force of gravity are balanced, so they should cancel out, those y direction arrows. So right here, the sum of the forces in the y direction should be 0, and we should be left with this force of friction, which is our sum of our forces. And so we got that right here by using vector addition. Now we had one more rule in our vector addition rules, so let's see what it is. The order you add the vectors doesn't matter. So we decided to add them green arrow, purple arrow, pink arrow, but we could have added them in a different order if we wanted to. So let's move that out of the way. And let's add this arrow first. Pink arrow, then green arrow. Well, if we have to put this arrow, the tail of this arrow on the head of the first arrow, they're going to be right on top of each other. So that one looks kind of funny, but they canceled each other out, which makes sense, doesn't it? And now we put this tail of the last arrow onto the head of the other arrow. So we move the tail of this arrow to the head of the green arrow. And so when we're drawing our resultant arrow, this one's kind of hard to see, but if we go back to our rules, the sum vector starts at the tail of the first vector and points to the head of the last vector. So the tail of the first one was that pink one, which is underneath the green one there. So the tail, this needs to start at the tail of the pink arrow and end at the head of the purple arrow, which was the last arrow we drew. And so it turns out that our resultant vector, or the sum of the forces, is the same length as the force of friction, which is our purple arrow. So we can add these together in any order that we want to. We could have added it together with the purple arrow first, and then the green arrow, and then the pink arrow, and our resultant would be the same, just like that. So we can add vectors in any order we please and get the same resultant vector. So I hope that gives you some sense of how we add vectors together.